Hello everyone. Today we are going to discuss this very important JEE Advanced PYQ. So this PYQ basically involves finding the area enclosed within the curve mod of x plus mod of y equals 1. So there are two approaches, actually three approaches. First is integral approach. Second is we call coordinate geometry approach, and third is our graph transformation approach. So the way I like to think of it is that you are transforming y equals to 1 minus x. You are applying two transformations, this and this. These transformations are not elementary, they require a bit of a rigor, but I'm sure most of the coachings cover them, so it becomes quite easy. Now the second approach is integration, which I'm not usually a fan of. So the approaches that I'll be discussing today are coordinate geometry and graph transformation approaches. So the coordinate geometry approach says that there are four possible combinations. First is plus x plus y equals 1. Second is minus x plus y equals 1. Third is plus x minus y equals 1. And then there's minus x minus y equals 1. So these are the four equations which are possible, right? We need to figure out the area bounded by this curve. Okay. So what we can do is we can just plot all of these out, right? We can just plot all of these out. So in this case, what happens is minus x minus y equals to 1. So the intercepts are -1 and -1, right? -1 and -1. You can just use the intercept approach. That is the simplest. So this is one line segment. Then there is another line segment which makes intercept 1 and 1. So this is one line segment. Then there's one line segment which makes negative intercept on x-axis and positive intercept on y-axis, both magnitude 1. And there's this last which makes it somewhat like this, right? So this is how you could do it. Now it's very easy to calculate the area of one triangle. It is very easy to calculate that. So what I usually suggest is that you use this approach. It works very well, and all you need to remember is x upon a plus y upon a equals to 1. Then a equals to length of intercept, right? This is all you need to remember for this approach. This is a very elementary approach. You can just find out the area enclosed by all four of these line segments, lines, and the area is going to be this. So you just need to figure that out. If I were to figure it out, it would be somewhat like if, right, 1 into 1, then it becomes root 2. Right. Oh, wait, 1 into 1 by 2, 4. So is the answer 4? Let me just check once. If the answer is 4, 2, okay. The answer is going to be 2. Right. So you could have done it any of the ways. You could have figured out this to be root 2, and this is a square, so root 2 into root 2 equals 2. That's how you could do it. Or what you could do is 1 by 2 is the area for each of these triangles. Then you multiply it by 4, so it becomes 2. You could have done it that way. Now the second approach, which is very interesting, case 2, or actually approach 2, way 2. This is a very interesting approach. So what it involves doing is it transforms the graph. So first we take the graph of x equals to negative y, which is somewhat like this, right? It is this. Then what we do is we introduce 1. So we replace y by y minus 1. So graph shifts 1 point upwards. That's what happens. All right. So it becomes this, if I'm not wrong. No, wait. Sorry, my bad. So the graph is y equals to minus x. So it should be like this. Then it shifts 1 point upwards. So it becomes this. We can erase the earlier graph. My god, I'm so bad at this. All right. So these are the intercepts. Then what we do is we have this equation now. Now we need to replace this by, we need to replace x by mod of x. So how do we do that? We do that by taking the absolute value of x as the input. So here the value as the input is 1, if it is 1 here. So the same graph is going to apply here. So it becomes somewhat like this, right? It becomes this. Now the second transformation that we are going to apply is x becomes mod of y. Y becomes mod of y. So how do we do this again? We know that we need to refer to the absolute value of y. So if at a point the value is negative 1, we need to consider the graph of positive 1, right? So if at positive 1 the graph was like here, then it comes here. So it comes down at all those given points. So it automatically plots this square. Now you just need to figure out the area of the square again. Now you could always figure it out by using 1 multiplied by 1 divided by 2, which is length into, breadth into height upon 2. And you get the area of a triangle. Then you multiply it by 4 and you get 2 as the total area enclosed by the line segments. Or you could always calculate the hypotenuse, which is root 2, and then just multiply it by root 2 to get the area of the square, right? So this is how you could do it. Now in the next video we are going to discuss a leveled up version of it, which could not be easily solved by coordinate geometry because it is a bit chunky and requires bit more rigor. So it won't be able to be solved by coordinate geometry. So you'll need to use graph transformations that time. We are going to discuss that soon. So just subscribe to the channel and hit the bell icon so that you can see the video once I post it. Well, thank you for watching, and if you have any doubts, just post them in the comments section. Thank you.